Welcome to today's video on WA3, where it will be testing you on three concepts: binomial theorem, parabolas, and circles. So what I have done is I have recorded three different videos for each of the concept. So part 1 will be talking about binomial theorem, part 2 will be talking about parabolas, and part 3 will be talking about circles. Alright, and I will not be going through the concept in details, okay, but rather I'll be telling you what you need to know itself. Okay, so do refer to your class notebooks and do refer to the examples that we have gone through in class so that you have a clearer picture. Okay, and do try the questions in the worksheet that has been given today so that you have more practice for tomorrow's WA. And drop me a message if you are unsure of anything. Here I will try to reply to you, same thing before midnight. So without further ado, let's move on to the first part, which is on binomial theorem. Alright, so for binomial theorem, okay, of course the use of binomial theorem is to expand binomials itself. The questions that they can ask you, they might rephrase it differently, but it always falls under these five categories over here. Okay, it will always fall under this five category. Um, so what you need to be able to do, of course, is to be able to apply the formula to answer the five types of question. Now, the formula itself you don't have to memorize because it's given in the formula sheet. Okay, um, and what you need to be able to do is to basically to apply the formula itself. Now, if you realize, okay, the formula is divided into two parts. One is for binomial expansion itself. The second one is, of course, the formula for n choose r. Now, this formula for n choose r, okay, will be very important for the last type of question, which is to find the unknown value of n. All right, so you realize that it looks complicated, but don't have to worry. We will talk about that later on. Okay. Also, within the first part of the formula, which is your binomial expansion, you have this n choose r equal to power, sorry, n choose r multiplied by a to the power of n minus r and b to the power of r. Now, this itself is the general formula for the r plus 1 term. Okay, and you must note that it's r plus 1 term and not the r term. All right, and this will be applicable to this question, this type of question, as well as to the last type of question itself. Okay, so without further ado, okay, let's take a look at each of the questions that can be asked. Okay, now the first type of questions that you can ask is to expand up to certain amount of terms. So for example, the question can tell you expand, let's say for example 1 plus x to the power of 10 up to the fourth term, for example. Okay, so you don't have to think so much. Okay, you just need to know what is a. So a equals to 1, what is b equals to x, n equals to 10, and then r, of course, is it changed with every term. Okay, so you will have 1 plus x to the power of 10 equals to 1 to the power of 10 plus 10 choose 1, 1 to the power of 9x plus 10 choose 2, 1 to the power of 8 x to the power of 2 plus 10 choose 3, 1 to the power of 7 x to the power of 3. And of course, don't forget, after you finish your expansion up to the fourth term, first, second, third, fourth, you will have plus dot 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 over here. Okay, don't forget this. Alright, it's very straightforward. Whenever they give you expansion questions, it's very, very straightforward. Alright, so that's for the first type of question that they can ask you. Okay, the second type of question that they can ask you is to find the nth term over here. Find the nth term. Alright, so for example, the question can tell you, let's say, find the fourth term in the expansion of, let's say, x plus x squared power of 10. Now, for this question, no matter what happens, you have to start off with the general formula itself. Okay, you need to start off with the general formula itself. So I have tr plus 1 equals to n choose r. So n is 10, r is, we'll leave that later, and 10 choose r, a is x, so I have, sorry, I have x to the power of 10 minus r and x squared to the power of r. Alright, so what happens over here is that I want to find my fourth term. So it's r plus 1 equals to 4. Please take note. Alright, a lot of people will confuse this with r equals to 4, and this is wrong because it is a r plus 1 term. So I have r equals to actually 3. So I have the fourth term will be 10 choose 3, x to the power of 10 minus 3, and x squared to the power of 3. And of course, you expand them and give your final answer itself. Alright. Now, another similar question that they can ask you is to find the coefficient of x to the power of r. So for example, I can ask you, find the coefficient of x to the power of 5 in the expansion of, let's say, x squared, no, let's just leave it as x squared plus 2 over x to the power of 10, for example. So for these kind of questions, you will still need to find the general formula first. Okay, always find the general formula first. So tr plus 1 equals to 10 choose r, x squared to the power of 10 minus r, 2 over x to the power of r. Now, unlike the previous question where you don't have to expand this, what you need to do is, of course, to simplify this using laws of indices. Okay, so if you need to do revise back laws of indices, so I have 10 choose r. Here I will have x to the power of 20 minus 2r. Here I will have 2 to the power of r. Okay, let's make it more interesting. Let's change instead of plus, let's change this to minus. So if I have minus, I have to include minus over here. So I have minus. So negative 2 to the power of r, x to the power of r. So realize for this question, actually, if I was to expand this correctly, you should get something like this. So I have negative 2 of r. Realize that I don't take out the negative from the bracket because I don't know whether r is positive. Sorry, r is even or odd. If r is even, then yes, the negative sign will disappear. But if r is odd, then the negative sign will still be there. So we just leave the negative sign there. Okay. Then I'll have 1 over x to the power of r. Okay, and of course, if I was to simplify this further, I will have 10 choose r, x to the power of 10 minus 2r. Then here I will have minus r. So I have negative 2 of r over here. All right. Now what's remaining to do? Because I want to find the coefficient of x to the power of 5. Okay. So what I will do is I will have 10 minus 2r minus r, which is the power of x in any term in the expansion, is equals to 5. Simplify it, I have negative 3r equals to negative. Sorry, I think this part off a bit. There was a technical glitch. I apologize. But anyway, okay, let's say the question asks you to find the coefficient of x to the power of 4 in the expansion of x squared plus 2 over x. Sorry, minus. We choose minus, right? So minus, oops, over x to the power of 10. So as I mentioned earlier, no matter what, we always have to find the general term. Okay, always find the general term for this kind of question. So tr plus 1 equals to 10 choose r, x squared to the power of 10 minus r, and then multiply by negative 2 over x to the power of r, and expand them, and I will have 10 choose r, x to the power of 20 minus 2r, negative 2 to the power of r, multiplied by 1 over x to the power of r. And I can continue to simplify this to get 10 choose r, x to the power of 20 minus 2r minus r, and negative 2 to the power of r. And then we equate the power of x over here to be the same as the power over here. So I have 20 minus 3r equals to 4. Okay, 4 doesn't work. Sorry, it's not 4, it was 5. 20 minus 3r equals to 5. So then I have negative 3r equals negative 15 and r equals to 5. Alright, then after that what I'll do is I'll substitute this r equals to 5 back into this general term itself. All right. Um, sorry if it's a bit messy. Okay. Yeah. So apologize for the technical glitch. Okay, moving on. Okay, so that's for the fourth type of question. Okay, for the third type of question. Okay. All right. So next, the fourth type of question that can come out will be an extension of the expansion question itself. Okay, so for example, they can tell you to expand 1 plus x squared to the power of 10, for example. So the key thing to do here, okay, is, or rather the first method where you can expand this, okay, is that you separate them into two parts. Even though there are three terms inside, separate them into two parts. The first part will always be only the constant, which is a. So let the constant be a. And the second part, you will group them together to make it b. All right. So what will happen will be you will have something like this: 1 plus x squared to the power of 10 equals to, let's say I want to expand up to fourth term, or up to term with x to the power of 4, x to the power of 3. Okay. So what I will do over here, okay, will be, first of all, over here, I will have 1 to the power of 10 plus 10 choose 1 to the power of 9, and I will have x plus x squared to the power of 1. Okay. Then I will continue on, multiply by, sorry, plus 10 choose 2, 1 to the power of 8, x plus x square. And I will continue on to the next term as well, 10 choose 3, 1 to the power of 7, x plus x squared to the power of 3. Because what I want is up to the term x3. So since I want x power 3, I know if I expand this, I will get x power 3. Okay. Then I won't have to continue any further, because if I continue, I won't get any x power 3. I'll get terms with x, the power of x higher than 3. Okay, so to save time, I will ignore that. Then what I will do is I will expand one each of them. Okay, so after that, you will expand and simplify. Very straightforward. Okay, so even if they give you a quadratic equation, or sorry, a quadratic expression to expand, okay, you can always separate them into two different parts. Okay, so that's method one, separate. Okay, method two, okay, is for questions where you can only, sorry, let me do this. Method two is only for questions where you can only factorize. So if you can't factorize the expression inside, you have to go back to method one. So for example, let's say the question gives you expand 2 minus 3x plus x squared to the power of 10. What you will do, okay, will be to factorize first of all. So I will have 2 minus 3x plus x squared to the power of 10 equals to 2 minus x, 1 minus x, the whole thing to the power of 10. And separate them. So you have 2 minus x to the power of 10, 1 minus x to the power of 10. And what you do next will be to expand them separately. And the third step will be to multiply them together. Now, this is very useful for questions where they have a few parts before that, and then they have this word hence. So if you the moment you see hence, then you have to factorize. If not, you can use method one itself. All right. So the last type of question that they can ask you is to find, or rather generally the last type of questions. Of course, there are other special questions that they can ask you, but the last question that they can ask you is to find unknown values of n inside the binomial expansion. So for example, they tell you I have, let's say, a plus bx to the power of n. Okay, they tell you that you know what's a and b. Then they tell you that the coefficient of x cubed equals to, let's say 5, for example. Okay, so what you need to do, no matter what, the first step will always be to find the general term. The second step will be to find R, because over here you have 3 already. Okay, so what you can do is you can use this to find R, okay, based on the following same step as this. After that, you can simplify your equation. You should get something like that. Okay, you will get n choose R equals to some number over here, a constant. Okay, and then from here we can use this to solve for n. And that's where you realize that this thing itself, you will need to use this formula over here. Now, honestly speaking, I have never referred to this part of the formula sheet itself. Okay, because it looks very complicated. Okay, so what we can do over here, let's just give a simple example. Let's say, for example, let me think of a question. Let's say they give you this from you simplify until the third step, you get something like this: n choose 3 equals to 1140. Looks complicated, doesn't it? Okay, and you have no idea how to apply this formula. Okay, but you know that r factorial is 3. So no matter what, the below part will always be 1 times 2 times 3. So the top part, you realize it will start with n. But I don't know how much I must continue. Okay, the tip here is very simple. The tip here is very simple. The numerator and denominator must have the same number of terms. Okay, so I have n, bracket n minus 1, bracket n minus 2 equals to, if let's say I have, let's say, n choose 2 equals to, let's say, for example, 45. So then I will have, start with the denominator, 1 times 2, and the numerator must have the same number of terms. So I have 2 terms over here, so I start with n, go down the series, I have n minus 1, and I'll stop there, equals to 45. Same thing, if let's say I have n choose 4, then I will have 1 times 2 times 3 times 4. I have n bracket n minus 1, n minus 2, n minus 3. Okay, of course. Okay, so these are quite straightforward. So to summarize everything, for this kind of questions as well as for this, okay, no matter what, you will be using the r plus 1 formula, the general term itself. Okay, there is another type of questions, okay, which is to find or rather find a in a plus bx to the power of n given some certain conditions. Now, this kind of questions, okay, it's not to be confused with the find unknown value of n, because n is power, here is inside this. So this will always go back to something like this. Right? So it's just an extension of finding coefficient of x power of r. Okay. Other than that, that's all for binomial theorem. I apologize if the video is a bit too long, and I apologize for any technical difficulty for this part 1. Okay, I'm still trying to get used to using this new tablet. Okay, this is, I don't know, I've taken actually took 4-5 hours to actually record this 18 minutes video. It's quite sad, isn't it? All right, so I'll see you in part 2 on the polynomials, sorry, on parabolas and circles. All right.